Um, let's get started with this session. So welcome back to session 9. Um, so I'm Hong Kai, assistant professor in the geography department at Texas A&M University. So I hope you enjoy your time at Redland and Esri, the biggest company in our field. I hope you enjoy the time, reconnecting with your colleagues, old friends, and also get to know the new people in our field, especially, we have amazing student assistants who are rising stars, and they will be working in the field for the in the future. So we also have people from online, so they couldn't join us in person, but fortunately we can be connected, through the technology. So so we all know that, like, for over a decade, when we entered the big data era, so we as geographers, we as cartographers, or either geographical information scientists, we try to extract the meaningful information from geospatial big data. So I remember when I was a PhD student, if I go to geography meeting talking about, I'm using social media data or geospatial big data, people were really excited. They were like, oh, that's interesting. That sounds exciting. So how do you use social media? How do you use geospatial big data? So nowadays, if you see a researcher, doing social media data analysis, geospatial big data analysis, the first question people ask would be, how do you avoid the misuse of geospatial big data? How do you mitigate the bias? So I'm very happy to moderate this session. So the session is the use and also the misuse of geographical information in social media. So in this session, we will have 4 amazing talks, talking about different contributions to how we use and misuse, and also avoid the misuse of geospatial big data. So the first presenter will be Debayan from the geography department at Texas A&M University. So he will be talking about, in social media, we need to extract the location information because we are geographers. Everything needs to be location matters. So he will be talking about how we can mitigate the uncertainties in geolocating social media data for disaster research. So, Steven, the floor is yours.
Thank you. Thank you for the introduction. So, hi, I'm Debayan. I'm a PhD student in Texas A&M University, and I'll be presenting on uncertainties in geolocating social media data for disaster research. So a brief overview of what social sensing is. It's a use of geospatial big data to reveal the socioeconomic characteristics, be it social media, be it taxi date trajectory, be it cell phone records, be it smart card data. But because it gives quite the insight into human behaviors or spatial interactions or even place semantics in real time. So it's also very easily accessible, and an ample amount of data that we get from social media data. So we see that we use social media data here because our biggest advantage is every user becomes a sensor, be it Twitter, be it Facebook, Weibo, Instagram. It has multiple users like crisis management or even disaster relief. But these data collected from the Twitter or any other social media, we need to geolocate them. So how we geolocate these is primarily through 3 methods. The first is tweet from, which is reported by the device GNSS. Usually it's obtainable if the user turns on their locational information. Secondly, we can get through tweet about, which is the location mentioned in the tweet content. And lastly, we can get it from the user from, which is the home location that is provided or inputted by the user himself. So running through what is tweet from and tweet location, it is actually considered the ground truth or the most accurate. We get the two types of it. One is the point precise geotagging. The other is the one with the polygon place space, but usually retweets will forgo that geotag. But the limitations of this is there's a lot of privacy concerns. So a very small portion is usually having a geotag location. For example, you can see a 2014 study saying it's 1 to 4% of the entirety of the tweets collected. And a more recent study, Linet, says it's 0.04%. So, and Twitter has also removed the feature of precise geotagging from 2019. And coming to user from or profile location, this is usually set by the user in the account level, and it can actually be geo-enriched depending on what the text they have put in. But the limitations of this is it's not frequently updated. It might not actually be a representation of where the user is, and it does not change from tweet to tweet. It's also a free-form character field, so it can actually have anything and not a location. And also geo-enrichment may err because multiple places may have the same name and they might locate it to some other place compared to where it is actually from. Coming to the tweet about or mentioned location, this is based on parsing the contents of tweet, usually through deep learning, machine learning, or LNP models, but may also support links. But it may also have positive, false positives. For example, a newspaper which has a city name will geolocate to that particular city. So as I mentioned, like for the limitations, address mentioned in the tweet does not necessarily reflect the user's current location. So based on the study you are doing, it might actually differ from the ground truth. So can I identify words which have a similar to location name and actually locate it to that particular city? And depending on the type of study, like I mentioned, for example, for rescue tweets, it would be the ground truth value. But for some other purposes, for example, electoral, it might add actually errors. So using it in conjunction with the other two methods will actually lead to misrepresentation of the data. And that is in the flight of making more sample data, it will actually add more uncertainty into the analysis. So the purpose of our study is to quantify the reliability of geocoded tweets in social media analysis for disaster management with these three geolocating methods, if they are used simultaneously. For we have observed a lot of studies which use all the three geolocating methods to locate the tweets to in a goal of increasing their sample space. So the objectives of this study is visualizing the percentage agreement between the geotag location from the three geolocating strategies in different stages of administrative boundaries and error distances, and showcasing the implications of this geocoding uncertainty in disaster management if they're used real time. So the data gathered, we have considered the Hurricane Harvey. As we know, the main affected states are Texas and Louisiana, and it was affected in August of 2017. And it's a very high impact disaster. So we anticipated a lot of tweets which will be related to it. And when we had filtered Hurricane Harvey related keywords, we had 47 million tweets. But among them, only 500,000 tweets were geotagged. So going through the brief methodology of this, like I said before, we used a keyword-based search to find the Harvey Twitter data. And then if the tweet was geotagged, then we filtered it out and used location tagger for toponym recognition for the tweet content to obtain the location for the tweet about and the user profile location to get the addresses from it. And you geocoded it with the Google Geocoding API. If the Google Geocoding API was successful, then we use that for the three analyses. So brief overview about the three analyses. The first one is the geolocating agreements. Basically, the location the location agreements between the administrative boundaries, be it state, county, or country level, or even error distances, for example, 1 kilometer, 30 meter, or a perfect match. And we also analyze it in different phases of the disaster. For example, the preparedness phase, the response phase, and the recovery phase. We did that because humans sort of behave differently in these three different phases. Because at first, the populace gets ready to face the disaster. In the response phase, it's more about the rescue efforts. In the recovery phase, it's going back to the pre-disaster period level activity. Going to the analysis, second analysis, the index calculation and comparison. We did the comparison with the two most commonly used indexes. The first one is the ratio index, which is the number of tweets per which is disaster related per capita of that particular county, which gives us a way of quantifying the situational awareness of the county. And secondly is the sentiment analysis, which we use the mean value of the sentiment score provided by a Vader tool, which is a sentiment analysis tool and has proved to be a very reliable tool for social media data analysis. And lastly, we are going to show some misuses of geolocating strategies through rescue and damage and see how these things are getting displaced across counties. So for the error distance, we have calculated it with the Haversine formula using the radius of the Earth and the latitude, longitude of the 2 points usually, and we get the displacement distance. Coming to our results, we can see that the agreement percentage for geotags to user profile location at the state level is the highest in Texas, which is one of the most affected states. And then it reduces as it goes away from it. Then the arrangement becomes more erratic. However, for county level, it shows no particular pattern and it is way more erratic than the state level. So we can say that at state level, these two methods would be interchangeably used. However, at county level, it is much more erroneous to use these two methods interchangeably. Similarly to in geotags to tweet about location, we see that Texas is actually not amongst one of the highest agreement percentage, whereas California is having the highest agreement percentage here. And we have noticed that there are more tweets coming out, rescue tweets coming out of California, which are directed to Texas. So in this period or in this particular study, we would say that in disaster management, we cannot use geotags and tweet about location interchangeably because it will have a lower accuracy. We see a similar image on the right side on the county basis. So to give an overview of all of that, we can see for the user from method, which is the top, the line here, it's starting at a country level of 91%, then reducing to 64%, then a gradual decrease. And for tweet about method, we see it's starting at 82 and then reducing to below almost 10%. So it's showing, giving us a view that how much percentage agreement user from has and how much percentage agreement tweet about has with the geotagged location. And as I said before, preparation period, response period, and recovery period, we took them separately to analyze, and we have found at most of the cases, response period has a higher percentage agreement. Only at certain places has preparedness gone above the response phase based on the user from data. But it's also true that in response period, there is way more activity and there is a possibility of interchanging these two locations while using for analysis. Coming to the usage examples, the discussion intensity per county, like I mentioned before, it's a quantification of the situational awareness per county. And we can see for the tweet about method, the correlation co-index is 0.5. And for user from method, the correlation co-index is 0.9 with the tweet from method. Depending on the error allowed in a particular study, these two can be interchangeably used for calculating discussion intensity. However, if we go to the next one for sentiment analysis per county, which is also a very commonly used index, we see that the correlation index is 0.014 for tweet about and 0.37 for user from, which is very low, and it would actually cause much more erroneous or false images if we try to interchange these two locations. Coming to the rescue and damage efforts, which would be more in a real-time basis, we use the keywords of Harvey Farm, Harvey Rescue, or Harvey SOS, and Cajun Navy. Sorry. To filter out the rescue-related tweets, we got 1,184 tweets and maximum of 181 tweets were displaced in a county. And for damage, we use damage, blackout, and power outage to filter out the data. And we got 2,400 tweets and a maximum of 105 tweets in a county to be displaced. And to give an example of how much it gets displaced, for example, this particular user is in Dodge County. His user profile location is in Dodge County, but his rescue request is in Harris County. So if this is replaced with those two data, it will show a very different map of where the rescue request is going to be. And to give an overview, this is all of the tweets getting displaced. For damaged tweets, we can see a person who is in Anne Arundel, but he's geolocated in New York, but making a rescue request in Harris. So this gives us the travel path of the displacement, or how a tweet is getting differently located. And the next is the displacement to Texas. So as a conclusion, we can say that they can be interchangeably used depending on if there is the locational constraints are higher, or if there is a very low factor of, very low factor of safety or more room for error. But if it is a very time sensitive effort, for example, rescue efforts or damage estimation efforts, then it would give a very false sense of severity, erroneous representation of maps. So it should not be used altogether. Rather, only the particular geolocating strategy that coincides with the purpose of the study should be used. Thank you.
We have time for questions, so feel free to ask questions. Okay.
On the map, you had, I think it was the agreement, and you had the states and you had the counties, and the counties didn't show any pattern at all. But the state showed Texas as that one, as like a, with the highest value. Like, it surprised me that the states around Texas didn't have like the next highest values. They're kind of far away. Like even Minnesota. Well, why do you think that is? Or maybe it's just one of those phenomena where, space doesn't really matter that much.
We did see it going like decreasing while going away. While it was more like here, but we don't know what's the reason. There is like erratic. We don't know why that is. But there are some. If you see the next in this map, you'd see the same for Arizona and Colorado as this. We see a lot of tweets coming out of there. So maybe the Twitter activity does have some implications on the percentage.
So you talk about the tweets that were displaced. So I'm curious about why these tweets were displaced, like whether, people in another place was tweeting for their relatives or families, in the disaster impacted area. So do you have an idea about why these tweets were displaced?
Yeah, so we had seen several of, several of these tweets, like were from their relatives actually, or even there are some which were tweeting for their friends, or even retweets. So those will not have the exact same location of the user from and the tweet about. So the tweet about would be our ground truth here.
Okay. Thank you. Yeah. Thank you, Debayan, for the amazing